Okay, so let's use what we just saw in the previous slide about taking this derivative, setting it equal to 0, and checking endpoints and all that. And let's find the absolute max and the absolute min of the function f of x equals x to the 2/3 power. Now, you could totally do this on your calculator, but since we're going to be calculus geeks, we're just going to geek it up to the fullest extent that we can. So let's just go ahead and look at the derivative of this guy, which is going to be 2/3 x to the negative 1/3 power. And since we're going to need to find zeros and critical points and things like that, I'm going to go ahead and write this as 2 over 3x to the negative 1/3. Oops, to the positive 1/3, not negative. All right, so we just need to figure out where this guy is undefined, equal to 0, and check endpoints. Okay, so the way we set equal to 0 is we look at the top and we set the top equal to 0. In this case, it's 2 equals 0. We don't worry about that. That's a false statement. The next thing we do is we take that 3x to the 1/3 power and set that equal to 0. Why? Because this is where we would be undefined. So we're going to discover that x to the 1/3 equals 0, because when you divide both sides by 3, that's what happens. So x equals 0. So I need this point right here to check. And I need to check also, if you'll notice, I have a closed interval here. So I need to also check x equals -2. And I need to check x equals 3. And what I'm going to do is I'm going to check all three of these values, and at one of these values I'm going to get a maximum, an absolute maximum, and at one of these values I'm going to get an absolute minimum. And when you check, we're going to actually check in the original function, because we want to know on our original function up here where the maximums and minimums occur. So if I've got x values for that, that's what I'm interested in. Okay, so here we go. We're going to look at f of 0. We're going to look at f of -2, and we're going to look at f of 3. And you may need your calculator handy, you may not. It just depends on how complicated the problem is. But on this first guy, we're looking at 0 to the 2/3 power, and that's 0. On the second guy, we're looking at -2 to the 2/3 power. So when you square that, you're looking at the cube root of -2 squared, -2, which is going to be the cube root of 4. Okay, so keep that in mind about where that is. I don't know. And then the last one is going to be 3 to the 2/3 power, which is going to be the cube root of 3 squared, which is the cube root of 9. So let's just think about this. I don't know exactly where the cube root of 4 is, but I do know that the cube root of 9 is bigger than the cube root of 4. So this is going to be my max value right here. It's also bigger than 0. Okay, so cube root of 9 bigger than 4, bigger than 0. So he's my max. And I know when I look at this that my minimum is going to be 0. Why? Because 0 is less than the cube root of 4 and less than the cube root of 9. So for this particular question, this would be my absolute min and my absolute max. Okay? And you can leave it as cube root of 9. You don't need to solve it out decimally or anything like that. It's totally fine how you've got it.